Hello, today we will be talking about intermolecular forces and their different types, but before we talk about that, we have to talk about the difference between chemical bonding and intermolecular forces. So chemical bonding, an example of a chemical bond would be something like HCl, where the bond is the electrons shared by the two atoms. Now, a bond, there's several different types of bonds. There's nonpolar covalent, polar covalent, and ionic, and the extent of this sharing varies depending on the type of bond. But in general, a chemical bond is just electrons that are shared between two atoms, an interaction between two atoms specifically. An intermolecular force is an interaction between two molecules rather than just atoms. Now that we define what an intermolecular force is and what chemical bonds are, we need to talk about the 5 different types of intermolecular forces. From strongest to weakest, we have ion-ion, we have ion-dipole, hydrogen bonding, dipole-dipole, and finally London dispersion forces, which are the weakest. Let's first take a look at what ion-ion looks like. Ion-ion, you're just simply going to take any ionic compound. Let's just say we have NaCl. This molecule exhibits ion-ion. If I take another molecule of NaCl, the negative part of the Cl will be attracted to the positive Na, and the positive Na will be attracted to the negative Cl. So this is an example of ion-ion. It's the easiest one to identify. Next one, I'm going to skip ion dipole and come back to that. I want to now talk about hydrogen bonding. Hydrogen bonding occurs when the hydrogen of one molecule is attracted to the fluorine, oxygen, or nitrogen of another molecule. You can remember these 3 atoms by saying fun. So hydrogen of one molecule is attracted to the fluorine, oxygen, or nitrogen of another molecule. So for example, if I take water, this hydrogen might be attracted to the oxygen of another water molecule. And perhaps we do a few more of these intermolecular forces. We have maybe another water molecule here that's where the hydrogen is attracted to the oxygen. And perhaps this oxygen is actually attracted to this hydrogen up here. And so now we can really see the difference between intermolecular force and a bond, where we have molecules that are attracted to each other. That's an intermolecular force in orange. These are intermolecular forces, and this specific one again is called hydrogen bonding. And the blue dashes are the chemical bonds. And so these are chemical bonds up here. And so now that we've talked about hydrogen bonding, let's now talk about dipole-dipole. So dipole-dipole exists in polar compounds and polar compounds only, and exists in all polar compounds. So for example, if I take something like formaldehyde has a structure something like this. I haven't been drawing lone pairs this entire time, but I suppose I'll draw it right here. So I would review your geometries, and this would greatly help you in understanding the different types of intermolecular forces and identifying them. If you were to review that, you would see that this is a polar compound because we have something that's slightly electronegative here between the carbon and oxygen. And then between carbon and hydrogen, there's relatively no change in electronegativity for the most part. And so we have one dipole on one of the bonds, while the other bonds don't have any dipoles. Therefore, this whole molecule is polar. And if a molecule is polar, it must contain dipole-dipole. And perhaps if I had another molecule of formaldehyde sitting right nearby, and this is not good geometry drawn or depicted, but I'm just going to draw it like that anyways, then you would see that this oxygen here would be attracted to this carbon here, and so formaldehyde can stack like that as well. That would be a dipole-dipole being depicted. And so all polar molecules have dipole-dipole. The last one, the weakest one, is London dispersion. It's not something that you really depict, it just exists in all molecules. It is the ability of molecules to create what are called instantaneous dipoles. So London dispersion forces create instantaneous dipoles. So if I took, for example, the water molecule, we may remember drawing those dipoles diagrams before. It would look something like that. Even a nonpolar molecule like carbon dioxide, where there's no dipoles or no net dipole, for a fraction of a second, molecules, whether they're nonpolar, polar, or ionic, create a very temporary dipole, because whenever electrons move in atoms or bonds, there's always going to be a region of positivity and negativity, which is what dipoles are. And so London dispersion forces create these weak, fraction of a second, transient, instantaneous dipoles that don't last that long. But these very fraction of a second dipoles allow nonpolar molecules and all the other types of molecules interact together. But they are very weak. Oops, actually I need to do this. And finally, ion dipole is unique in that it requires an ionic compound, like NaCl, to be dissolved in a polar solvent, such as water. The other intermolecular forces, we were able to get away with it being just one molecule, so we were able to talk about the intermolecular forces in water, the intermolecular forces in formaldehyde, but now we need, in order for ion dipole to exist, we need an ionic compound and a polar solvent. So if I just had NaCl, we would have ion-ion. However, if I have an ionic compound and a polar solvent, NaCl and water, I get ion dipole forces. And you may remember drawing a diagram like this before, maybe, maybe not. If I draw a water molecule, and I draw a partially negative up here, and a partially positive over here and here, and if I dissolved NaCl in water, you'd see that the positive NaCl is attracted to the partially negative oxygen, and the negative Cl is attracted to the partially positive hydrogen. You may have not known the name for this before, but this is a type of ion dipole interaction / intermolecular force. That was all the different types of intermolecular forces, and we've defined what they are as opposed to chemical bonds. Up here, as we go up here, we get stronger intermolecular forces. Some key tips and things to remember is that all molecules contain London dispersion forces. all nonpolar molecules only contain London dispersion forces. All polar molecules contain at least dipole, dipole, and London dispersion forces. If it is a molecule that has hydrogen bonding, it will contain the dipole-dipole London dispersion and also hydrogen bonding. Water would be one such example that contain all three. All ionic compounds contain ion-ion and London dispersion forces. And finally, ion dipole forces require an ionic compound and a polar solvent. And like we talked about, molecules may contain more than just one intermolecular force, and oftentimes they do. And thank you for watching this video, and I hope to see you next time.